Hello everybody. Today we'll be doing our chemistry Form 4 chapter 3 empirical formula. So for this case, right, empirical formula, this time we'll be using experiment we so-called magnesium oxide. We do to determine the empirical formula for our magnesium oxide. So here, this is what we'll be doing in our lab. If let's say you did it in your school, you probably know what happened here. So here we have our lead. Of course, we have a lead. We have our lead, the one that you tutup lead. And we have our crucible. We have our fire clay triangle, tripod stand, Bunsen burner, magnesium ribbon, and tongs to remove the lead. In this case, right, tongs to remove the lead, I mean, you can actually ignore it. Magnesium ribbon basically means magnesium. The ribbon, you can just ignore it. It's the same thing. And Bunsen burner, tripod stand, these are just practice that you need to know. On exam, they won't ask you to label it. Unless if it comes out in Amali, then it will be a different case. So here it says a given material, you have your crucible and your lead together, it's 38.50. Crucible, lead, magnesium ribbon together, you get your 39.70. Crucible, lead, and magnesium oxide, you get your 40.50. Okay, listen up. Magnesium ribbon is just your magnesium, as simple as that. But magnesium oxide is totally different case. Magnesium oxide means there's magnesium and oxide together, while magnesium itself, it's by itself. So they are, of course, different mass between them. So let's start the question first. So the question says, A, what is the meaning of our molecular formula? Again, molecular formula. What is it? Either it's an empirical formula or molecular formula. It is a chemical formula first. So there goes your first marks. You says that, oh, it's a chemical, so I'll change my color first. It's a chemical formula that, okay, what's this? This is molecular formula, all right? Molecular formula means shows the actual what? Actual number ratio, right? Actual number ratio of, don't ignore your atom, of each element in a compound. This one marks, right? Some of my friends, well, during experience, some of my friends, they just ignore it because it's 1 mark. But for me, right, in my case, I don't let go of this 1 mark because this 1 mark is really easy to get. The moment when you understand the definition, the 1 mark is not a problem, and through the definition itself, it tells you what it means. While molecular formula, we know it shows the actual number ratio of atoms, right? How about empirical formula? Empirical formula, of course, vice versa. It shows you the simplest whole number ratio of atom of each element in a compound. You can actually refer back to my previous video. So I'm not going to talk much about this. It's just 1 mark. Next. Okay, based on above results, determine the empirical formula. Listen up. Empirical formula finally. Empirical formula of magnesium oxide. Okay, write it down. Magnesium oxide, our formula MGO. For information, why is it MGO? Because Mg is actually your cation. Magnesium is your cation where you have 2 plus here up there. While oxygen is your anion, you have 2 minus up there. So what happened, just in case your basic is really bad, I'm going to show you what happened here. Your plus and minus, you remove it. It becomes neutral, right? So it's gone. Now what is left is your 2, right? So 2 and 2 together is also neutral because you have two positive and 2 negative. You just get back 0. So it turns out to be neutral. And in this case, you realize that MgO, there's no such thing as Mg2O, MgO2. No, because 2 positive charge and 2 negative charge, they turn out to be neutral. And there's no any other spare numbers out. So there you go, you get your MgO. Next, determine, they want us to determine an empirical formula. This is what they are asking. Write a key there. And given relative atomic mass is oxygen is your 16, magnesium is 24. Now, some people really ask, the teacher, do you need to remember the relative atomic mass? What I'm going to say is, it depends on you. But the more you do, what I'll say is the more you do, the more you'll get to remember it. For example, like carbon is 12, oxygen is 6. Like this. Magnesium is 24. Hydrogen is 1. But I wouldn't say that Sometimes SPM will always provide. I wouldn't say that, I wouldn't promise that, but usually they will provide. So of course, to determine the empirical formula, the whole world knows that we need to do the table, right? So let's start by doing the table. So the table, first thing we have to put is our element. What element do we have? We only have two, right? Magnesium, refer back to the question, please. Magnesium and oxygen. Do another line. Okay. And after our element, what do we have? We have our mass. Okay. And in exam, right, please put a bracket and put a gram inside because you're calculating it in terms of gram, not kg, not kilogram, please. Gram. And is the mass given? The mass is not given. I mean, it's given, but you need to calculate it by yourself. Okay, now we'll start by doing the mass first. Refer back to the question, what it says. Oh, given the mass, oh, okay, so I know that crucible and lead together itself is 38.50. Crucible, lead, and magnesium is 39.70. That means, right, in this case, I'm finding magnesium itself. That means I'm finding magnesium ribbon itself. So agree or not, guys? Agree or not? To find the magnesium, okay, I'm going to cut the ribbon just in case you're confused. To find the magnesium itself, you need to take away your crucible and lead. That means, right, basically you take 39.70 minus off your 38.50. And then what you're going to do right now is you cut both of these together. You cut crucible and the mass of your crucible and lead. What is remaining is your magnesium, the mass of your magnesium. So write it down. The idea is like this, 39.70 minus of your 38.50. Refer back to the table. And what you're going to get is 1.2 as your mass for magnesium. Now, for our oxygen, same thing. Refer back to the question of see, crucible and lead, I cut it off together. I cut it off. And magnesium oxide. See the difference? Magnesium, but for the last one, right, there is an oxide behind. So, meaning, by taking 40, as you can see, it's more heavier, 40.50, the minus of your 39.70, you will get, agree or not, you get your oxide. Because you cut this off, you cut your crucible and lead and magnesium together. What's left is your oxygen. So again, cut and paste. Okay. 40.50 minus of your 39.70. What you're going to get is 0.8 as your mass. So now we know that a mass of magnesium will be 1.2, the mass of oxygen will be 0.8. Now, after mass, everybody in the world knows that. If you don't know, I don't know. Everybody in the world knows that, oh, it's number of moles. To find the number of moles, what do? Sub in the formula. Number of moles, okay? Number of mole in terms of MOL, of course. Now, number of moles, we have our mass, and now we also have the atomic mass, right? So we have two of them. One of the formula is what? Mass divided by molar mass, right? So mass is 1.2. Molar mass, of course, for magnesium is 24. It's given in the question. Please refer back. 24. Now, what we get is going to be 0.054. Next, for our oxygen, 0.8. Oxygen, rated atomic mass, how much? 16, right? Divided by 16. And then what you're going to get is 0.05 as well. And of course, nevertheless, there's one last thing we need to do. Since we all know that through the definition itself, it says empirical formula shows the simplest whole number ratio. That means, right, the only one whole number, right? So of course, in this case, you're going to make it into whole number. How do you make it? You divide them each other and become one itself. Meaning, this is what you're going to do. Hang on, changing my color. Okay. Simplest whole ratio. Simplest mole ratio. Oh, 好啊。嚟， simplest mole ratio. That means 0.05 divided by 0.05, then you get 1. Or here as well, 0.05 divided by 0.05, then you get 1. So meaning, do we get our whole number here? We get 1, right? Is this a whole number? Yes, it is. So directly, in this case, you already find your answer. Your answer is what? Your answer is you need to write empirical formula first. Write down empirical formula. is equals to MGO. Done. Here, how many marks here? Sorry. Here you have your how many marks? 3 marks. Then yes, here you go, your full 3 marks. On the exam, in case after you divide them, you still haven't get your whole number, you need to times them, multiply them together to get your whole number. Okay. Okay, let us continue the question. So here, let's see. Uh, okay. So previously we have done this, right? Our to determine the empirical formula of our Mg magnesium oxide. Next, write the chemical equation for reaction in the experiment. Okay, chemical equation. Because as you can see, go back, refer back. We have a what? Magnesium reacting with our oxygen. So again, let me try to label it. So magnesium here reacting with the oxygen outside, from outside, meaning right, okay, let me try to explain a little bit, just a little bit. Okay, so what happened is that the magnesium, we are burning the magnesium ribbon inside, and while we are burning it, we are opening the lid intervals. That means we open and close, open and close, open and close like this. And then the reason we open and close them is to allow oxygen gas go inside and react with the magnesium ribbon. Understand? So obviously our chemical equation for the reaction is magnesium and oxygen reacting together, right? So here, let's write down. So magnesium, Mg, reacting with oxygen. Oxygen. Okay. And oh sorry, there's the two. And magnesium and our oxygen, because oxygen, right? O2. We get our MgO. Yes, MgO. How do you get it? Okay, it's as simple as that. Okay, MgO because Mg2 plus O2 minus. You remember the one that teach you just now? That's how you get MgO. And next, you gotta balance the chemical equation, right? So how do you balance it? As you can see here, there is 2 oxygen. However, here's only 1. So what you're gonna do is you're gonna put another 2 here, and there's 2 magnesium, right? Suddenly become 2 magnesium, right? So we put another 2 here. So this question done. This question done. Nice. Next, why was the crucible covered with the lid as soon as the magnesium started burning? Why? Why when the magnesium is burning, right? We need to close the lid as soon as possible. As simple as that. Remember the reason why I told you that, we need to cover the crucible. It's because we need to open and close intervals. Why? We cannot just open or cannot just close, because you need to allow oxygen gas to go inside and react, right? And we covered it as soon as it started burning. I mean, burning of magnesium oxygen produce white film. So if you don't cover it as soon as possible, what happens is that the white film will come out. So meaning, right, the reason we need to cover it is to prevent the white film from escaping to the surroundings. So we're gonna write down is to prevent the white the sorry the white film of magnesium oxide from escaping to the surrounding. As simple as that. You close it. Why? Because you want to prevent the white film of magnesium oxide from escaping to the surrounding. You open it. Why? You open it because you want to allow oxygen gas react with your magnesium to form magnesium oxide, which is your white film. Understand? Next, okay, this one. Why is the method not suitable to determine the empirical formula of copper 2 oxide? Come, copper 2 oxide. Copper means Cu, right? Cu. Now copper 2 oxide CuO. Cu2 plus O2 minus. That's why you get neutral. CuO. Okay, the reason is very simple, because copper compared to our magnesium is much more lower. So it's much more lower in our reactivity series. So if you refer back to the textbook, you realize that magnesium, the location of a magnesium is actually higher than your copper in the ECS series. So copper is less reactive, right? So what you're gonna say is copper is less reactive compared to your is magnesium, you can just write copper is less reactive. Sorry, my words is a bit ugly. Copper is less reactive towards your oxygen compared to your magnesium. Meaning, right, copper is not that reactive as your magnesium when it comes to reacting with oxygen. If we go back to your textbook, we realize that there is a series of elements that are reacting with your oxygen, and you can see which one is more reactive, which one is less reactive. You refer back to that diagram, okay? Next, the reaction between, you can say, another marks is the reaction between copper and oxygen is really slow. That's why it's not really suitable. What happened to my pen? So first you're gonna mention copper is less reactive with towards oxygen compared to your magnesium. Then second marks is what? Is your reaction. The reaction between copper and oxygen is really slow. That means if it's less reactive, then the reaction between them will be slow. The Let's continue. Sorry, my laptop just shut down just now. Very, very bad. Okay. Go back to our question. Again, copper is less reactive towards oxygen compared to your magnesium. Refer back to the graph about the diagram in the textbook. And the reaction between copper and oxygen is low. So as you can see, when it's less reactive, okay, the reaction is slower. If it's more reactive, that means your reaction will be faster. Makes sense, right? Logic. Okay, let me remove all this stuff. And we'll move to the next one. The next one, what it says, explain on how to ensure that the reaction has completed. Okay, how do you ensure this one? You just have to know. I mean, basically, the more you do questions by chapter, the more you remember. Explain how. Okay, so explain this answer is fixed. Is fixed. So the answer is basically repeat. Sorry, repeat the heat, heating, cooling, sorry, cooling, repeat the heating, cooling, and wicking, wicking process until a constant mass is obtained, which means that I need to repeat this. Sorry, which means that I need to repeat my heating, cooling, wicking process until a constant mass, that means a fixed mass is obtained. That means like 56 kg, about 56 gram, that means 56 gram, 56 gram, 56 gram, 56 gram, 56 gram, like this. This is what it means by constant mass is obtained. So repeat your heating, you heat it, you cool it, and you wick it until a constant mass is obtained. That's where the reaction has completed. The moment when you realize that you find out that I just get a constant mass, it's not changing. That means my reaction has completed. That's what it's trying to say here. Next, these two precaution steps that must be taken during the heating process. Okay, remember what I told you earlier? There's two things. Remember, you need to open and close the lid. Why? You need to open and close the lid. I mean, you need to open and close the crucible. Why? Because you need to ensure that intervals. You need to open and close intervals. Why? Because you need to ensure that you need to open it because you need to ensure that the oxygen can enter inside and react with your magnesium. And you need to close it because you want to prevent the white film of magnesium oxide from escaping to the surrounding, right? Write it down, please. Write it down. That's your answer. So put it in words, it will be something like the lid must be open intervals to allow oxygen gas to react with your magnesium ribbon. Magnesium lah. It's the same thing. Next, second mark. They want two, right? Two. Next, you need to close the crucible to ensure you need to cover the crucible is quickly covered again to ensure that the white film again crucible is quickly covered again to ensure that your to ensure that the white film of magnesium oxide, the white film of magnesium oxide do not escape to the surrounding. White film of magnesium from to just quickly cover again to ensure that white film of magnesium oxide do not escape to the surrounding. Or you can say like the crucible is quickly covered again to prevent the white film of magnesium oxide from escaping to the surrounding. Just that the sentence a little bit different, but it's the same thing. Crucible is quickly covered again to ensure that white film of magnesium oxide do not escape to the surrounding. Done. That's your 2 marks, I guess. If I'm not mistaken, it's 2 marks question. So yes, thank you for watching, and I'll go to the next video. I'll make another video. Thank you.